right. Well, good morning, good afternoon, good evening, everyone, and welcome to the world's most exciting classroom. My name is Joe Grabowski, and I'll be your host for today. We have a lot to catch up on. Last night, in fact, we started another version of the world's most exciting classroom. So with the Oosterschelde being on the other side of the world in New Zealand and the time zones being so different, we're now going to do 2 live events a week. One for classrooms in North America, the UK and surrounding areas, and then one for Australia, New Zealand, and those surrounding areas as well. So it was a pretty fun event last night, and we're going to use a little bit of the material from last night in today's event as well. And you're going to see some very familiar faces if you've been tuning in the last little while. So what is the Oosterschelde doing right now? A quick update. I'll bring up the map. And the easy answer is not a whole lot. You can see here that over the last few months, we have crossed a massive expanse of the Pacific Ocean. And as you can imagine, getting supplies, the right materials and tools needed to do repairs and maintenance on the ship have been very, very difficult. So over the last few weeks and over the next few weeks longer, the ship is here on the North Island of New Zealand. I'm going to zoom in a little bit. And it is undergoing some of that maintenance. So you can see it has not moved from where it's been the last couple of weeks, but not too long from now, it will sail a little bit down here to the Auckland area. And there we're going to have another group of Darwin leaders come on board and join us for their projects. I think we'll probably have maybe 5 or 6 Darwin leaders doing some cool projects in the Auckland area. Of course, we'll get to meet some of them and see what some of their projects were and some of the work that they did. So that's where the Oosterschelde is right now. It won't be too long, roughly around Halloween, the ship will set sail for Sydney, Australia. Then we will spend a couple weeks in Sydney, and we have a ton of really cool live events planned from Sydney, New South Wales, maybe even some stuff from down here in Tasmania. So you're going to want to stay tuned for those events. Okay, that's about all I can say about the Oosterschelde right now, hanging out on the North Island, soon to be in Auckland, and within the next couple of weeks, we'll be starting to sail towards Sydney, Australia. So I'm going to come back from that screen share now, and we're going to start off right away with one of our guests joining us today from Peru. So probably a few months ago now, we connected with Daniel Cáceres Bartra, and he was one of our Darwin leaders in Peru, working on a really cool project. So I have him backstage right now, and we're going to have a little catch up with him. So let's get Daniel in here with us. Hey, Daniel, how are you?
Hey, Joe, pretty good. Now here in Peru, with the climate starting to change, we're in spring now. So, yeah.
Excellent. Well, it's great to see you again. Some groups might have met you previously, but we always have new classrooms joining. So let's start off. Why don't you introduce yourself and tell us a little bit about what you do?
Well, hello, everyone. I am Daniel Cáceres. I am a marine biologist from Peru, and I was at the Oosterschelde in Concepcion in Chile back in February, and I did sea otters. So you're going to be seeing the documentary in regards to sea otters.
All right, perfect. And so, tell us a little bit about your time in Peru. Was it challenging being out in the field, putting together the video? It's tight timing. So what was that like?
So well, because I am from Peru, I'm a little bit used to cold water. You know, our water ranges from 14 to 18 degrees sometimes here in the coast. But now that I was in Chile in Concepcion, the water was much colder because we're farther south. So it was very interesting to see just how on the same coastline, just around 6,000 kilometers away from home, um, we could see such a different type of temperature around in the area, and also how similar biodiversity, because we have the same sea otter species in Peru because they share with Chile, how we could have some of the general threats that we have in my home country, 1,000 miles away from a couple thousand miles away from there. So it was pretty interesting also knowing the neighboring country, which was very good. So I think compared to some of the Darwin leaders, I usually meet people from around different continents. I just had a neighboring country, so it was really good to see the neighboring country, to see their similar issues that we have, and how our same species have different types of conservation strategies, for example.
Yeah, very cool. Well, we played your introduction video the last time we had you join us. This week, I have your second video, which is going to focus a little more on some of the threats that the otters are facing and maybe touch a little bit on the conservation. So I'm going to play that now. We do have classrooms joining us via YouTube. So if you have any questions, I'll actually give a shout out. I see Miss Colburn's class saying hi from Hamilton, Ontario, here in Canada. If you have any questions about the otters, about Daniel's time, Concepcion in Chile, you can put them into the chat for me. A shout out to our grade 6s at St. Isabel who are backstage with me. If you do have some questions for Daniel, just send me a message in the private chat and I'll bring you in after we play the video. So what do you think, Daniel? Let's play this video.
Perfect.
All right, here we go. Loading on my end, and we should be live now.
We're now in 2024. We're in Caleta Chome in the peninsula of Hualpén. And you would have thought that probably after more than 60 years of the killing of sea otters being banned, that the population would have recovered. But actually, that is sadly not the truth. And that is mainly because of two reasons. Mainly because of human expansion. Just to the nearest city where I'm standing today, which is 20 kilometers from here, which is the city of Concepcion, there are around 200,000 humans. That's more humans population than all the sea otter Lontra felina population left in the whole world. The main causes of loss of biodiversity throughout history have mainly occurred because firstly, direct hunting, and then by loss of habitat. Now the sea otters, we cannot hunt them, we cannot kill them, it's completely illegal, but they're still facing many problems. Problems, for example, the feral dogs, the dogs that we have seen in the area that go into the coastal rocky reefs and areas and kill the sea otters directly for fun or for food. We have also seen the harvesting of algae. The reason why the extraction of macroalgae is so harmful for the sea otter is because a suitable place for the sea otters are places where there's a lot of food source available. And the macroalgae like this Luga negra provide the main engineering for the ecosystem for its food source like fish, mollusks, and crustaceans. Without the macroalgae, the food source of the sea otter will not be available. And there are also new problems searching in the habitat of animals like the sea otter. One of these new problems that I've searched in the past half century is plastic pollution. As we can see in this sandy beach, the ocean has been throwing out different types of plastic that are evidence of how the ecosystem is filled with them. Most of this plastic has probably come from the input of the Biobío River, from the citizens that live in the coastal areas, and also from tourists that just come and visit daily. And all this plastic, with the sun, with the movement of the water, with the movement with the sand, can eventually become microplastic. This microplastic can eventually be digested by marine animals and eventually get into the food chain into the sea otters. And that's why we have our friend, Andrea Cisterna Concha, a biologist who's studying the microplastic present in the feces of the sea otter. Andrea, ¿tú crees que nos puedes contar un poquito sobre el estudio que estás realizando con las heces de las nutrias?
Claro, bueno, mira, primero que todo, las heces de los distintos animales nos pueden entregar diferente información. Puede ser entre la alimentación, el estado de salud de la población o de los animales, y en el último tiempo se ha empezado a investigar sobre el microplástico. ¿Qué es el microplástico? El microplástico es un polímero sintético sintético que va desde el tamaño de 0,01 a 5 milímetros, y este puede ingresar al organismo de los animales a través de dos vías, una vía directa y otra indirecta. La vía directa es cuando el animal está alimentándose en el agua, por ejemplo, y va a cazar o va a alimentarse, y este microplástico ingresa a través de la alimentación al organismo. Y la vía indirecta es cuando ingresa a la trama trófica del alimento de este animal. ¿Cómo es esto? Es, por ejemplo, si es desde el organismo más pequeño, que es el pez, después comido por el crustáceo, y finalmente ingresa a través de esa trama trófica a la nutria.
Y Andrea, hay algo que me habías contado, que era que en las poblaciones del Pacífico Norte y en Europa ya se habían encontrado en las heces microplástico. ¿Podrías contarnos un poquito sobre eso?
Sí, hay dos estudios en particular, uno con la nutria de Europa y otro con la nutria de América del Norte, en el cual ya se han encontrado partículas y perlas de microplástico.
Y acá todavía en el Pacífico Sur todavía no.
Todavía no, y acá en la población de Caleta Chome todavía tampoco hemos concluido que consumen microplástico. Pero estamos en investigación.
Muchísimas gracias.
The main reason why the sea otter population is not recovering is the same reason as why most of the biodiversity of the coastal marine rocky ecosystems is not recovering and is actually being lost. And that is mainly because of habitat loss, primarily because of human expansion. Human expansion throughout the years has caused settlement, has caused also extraction of activities in the coastal areas, and mainly has contributed with disturbance. Disturbance is activities like this ones, as what we're on, that contribute to noise, odor, and even presence of the humans in the areas. Just the simple presence of us in a habitat can motivate animals in the coastal areas to move away from home.
And here we have Fernanda Silva, a member of the community who's also joining the investigations that are being done here in the area about the chungungo. Fernanda, ¿podrías contarnos un poquito sobre cómo ha sido la transición de la visión hacia el chungungo acá en la zona? ¿Cuál fue la visión inicial y cuál es la visión actual que tiene la comunidad?
Así es. Bueno, acá en la caleta la gente conoce al chungungo como gatito de mar, es parte de nuestra biodiversidad marina, pero nuestros turistas no lo conocían y es lo que han venido a ver hoy en día. Hemos dado mucha importancia a que conozcan esta especie que está en grave peligro de extinción en nuestro país y que lo tenemos acá en nuestras costas, así que ahora lo protegen, lo conocen y lo valoran.
Buenísimo, Fernanda. ¿Y cuáles son las las acciones que está tomando la comunidad frente al chungungo para promover la investigación, digamos?
Primero participando en torno a la investigación que se están haciendo acá, dónde está la madriguera, cuándo anda un chungungo en la zona, si está comiendo o no, eso nos van diciendo la misma gente de la caleta, y también promoviendo el tema de respetar la zona donde ellos viven, no tratar de deforestar los bosques marinos, y el tema de los perros silvestres, no dejarlos muy cerca de que lleguen a la playa donde esté la madriguera.
Buenísimo, Fernanda. Muchísimas gracias.
There's also a new issue with the sea otter. We have new diseases that are coming. Last year in 2023, it was reported that the avian flu arrived in the sea otter population. So instead of winning battles for the sea otters, we're getting new ones.
All right, Daniel. So that was another beautifully produced video. Very nicely summarized the challenges that are being faced. So at one point, the population fell so far because of habitat loss and hunting. So you would think being protected, hunting being banned, that you'd see the numbers go up, but just new problems have come along. Too many people, plastic pollution, diseases. Sounds like the otters are having a tough time.
Yes, completely. And that's the thing that we see in the trend with marine mammal biodiversity loss. Usually at the beginning, all types of biodiversity loss first occur because of direct human hunting throughout history. 30,000 years ago, when humans first arrived in the Polynesia, for example, 17,000 years ago, when humans first arrived in the Americas continent. And then, so most of biodiversity loss occurred just because of direct hunting. So we thought when banning hunting directly was going to help populations recover. But then we realized that now most of the biodiversity loss occurs now not only because of direct hunting, but rather because of habitat loss. Because as human population grows, we're 8 billion humans right now. When 10,000 years ago, we were only 1 million in the whole planet. When human populations grow, also range of distribution grows. That means we're colonizing new ecosystems relatively new. And that's why also in the video, I talked about the population of the sea otter. You know, at the beginning, 17,000 years ago, there were more sea otters than all humans in the Americas. And now just in that small part of Concepcion, there are more humans than all the sea otters left in the world, marine sea otters left in the world. And when we're humans, we colonize new places. We bring plastic with us. We bring other invasive species like dogs, cats, that are now one of the main threats of the sea otter. And we're also bringing our local economies that are needed, like algae algae extraction, which has affected also the habitat of the Chungungo.
All right. Well, Daniel, I'm going to take a couple questions in just a moment. So if you are tuning in via YouTube, send in some questions there for Daniel. Our grade 6s in St. Isabel, I'll check with you in a moment to see if you have a question or two for Daniel. But one more question from me. Your third video is going to kind of deal with, well, it's already finished, but it deals with solutions and what we could do differently, maybe what the organization is trying, maybe you had some ideas. So what do you think? What could be done differently to help sea otters?
We definitely, what we have realized now is we have to protect the habitats. We have to protect the habitats for sea otters to be able to live freely, just to move from rocky reef to rocky reef, to move from area to area, because they have to go through beaches when they move from one area to another. We have to protect their nests. So that what we have to do now to protect the habitat is one of the main proposals that Chile has already is MPAs. Chile is one of the countries with the biggest amount of MPAs, and what we need mostly is no take or no use MPAs, areas with exclusive space just for biodiversity, kind of areas how they were before humans arrived, before just leaving this type of small spaces for them to just live freely with no human interaction, with no invasive species interaction like dogs and cats, with no extraction activity, will help recuperate the populations of that.
All right. Well, let's check in with a few questions here, Daniel, before we let you go. We have some grade 6s at St. Isabel joining us. I've just popped them in. There they are. Hey, grade 6s. All right. Good to see ya. Do you have any questions for Daniel about being a Darwin leader, being in Chile, about the sea otters? We'd love to grab one or two.
Come on. Who would like to come up first? Luke, come on.
Hey, Luke.
Hi. As you said that while we're building cities, the habitats are getting destroyed. What type of habitats are getting destroyed?
One of the habitats that I talk about is coastal habitats mostly. But we now know that not only cities are affecting coastal habitats, but we know now they're affecting directly the marine habitat. Because coastal cities, for example, not only modify the coastal areas, but they also have runoff systems and change the water cycle over there. So now we're seeing more acidification in the marine areas next to the coast. We're seeing more deoxygenation in the water also next to the coast. And we're also seeing more efficient extraction when it's occurring. So I'm talking mainly about coastal ecosystems when I talk about the sea otter, but when human expansion occurs, not only the coastal area gets impacted, but also the marine environment directly, the water column.
Okay. Thank you.
All right. Great question, Luke. You guys have one more there?
One more? Anyone? Nathan? No? Terry? No?
That's okay. If you think of another one, you can just let me know in the chat and I'll come back to you guys.
Thank you so much.
All right. So I do have a few in the chat already. I want to shout out to, we've got Miss DeMayo's group joining us in Connecticut. So hey to them at Salem School. But a few questions from Miss Coburn's class, Daniel. They're wondering, it looks like the sea otters move in a group and they're together in groups. Has that changed at all since their numbers have been falling?
I wouldn't know exactly how to answer that question, but yes, they're a very gregarious group. They like to be in groups. They like to be in the baby sea otter stays with the mother for a while. They have a lot of parental care at the beginning, for example. But I, I would not be able to answer that question. But something that we do know is that the migration pattern is expanding by groups. They're going farther north and they're going farther south because of climate change. Because usually this sea otter species is distributed from the north to Peru is the limit, and on the south, Argentina is the limit. But as glaciers start melting, their cold range, their cold distribution range gets expanded because they have very little blubber compared to other marine mammals that have very thick blubber. So they get cold easily compared to other marine mammals. So now that we're having glaciers melting and it's getting less colder on the farther south, there's more groups that are migrating south. And now that also we're having change in the northern part, we're having an expansion in the northern current, in the northern hemisphere distribution range. I mean, that's going farther north also with groups.
All right. I've got another question here from Jed, and Jed wants to know, why are they ingesting plastic? Can they not sense or feel that it's different?
It's not plastic directly that they eat plastic, but it's microplastic, and it goes directly through the food chain. It's not that they ingest it directly like other animals, because the microplastic, now we have microplastic, which is very, very small plastic. We also have nanoplastic, which is much smaller than the microplastic now, and it goes through the food chain, through phytoplankton, and then phytoplankton gets eaten by other animals, by sea cucumbers, by sea urchins. And then what they eat mostly is sea urchins. They eat sea cucumbers, for example, that filter this phytoplankton. So it goes through them through their food. It's not that they ingest directly the plastic like other animals, for example.
All right. And that's no different for us. When we eat fish from the ocean, it's gone. The microplastics have gone up the food chain. And then when we eat those fish, we're ingesting those microplastics as well. So it's not just the otters. It's us as well, and many other species. Okay, last question here for you, Daniel. The otter behavior, how do they react to humans after, years of being hunted? Do they keep their distance? Are they kind of so-so with humans? How do they react when humans are near?
Well, it's very, very interesting because, the hypothesis of marine mammals when first humans arrive is that they mostly behave like they behave in Galapagos, for example. Is that most marine mammals had no fear of humans at the beginning, but it's mostly through hundreds and hundreds of years of hunting, because we know even the indigenous communities of Chile used to hunt the sea otters. Even Darwin talks about running into a tree in the middle of the forest in the southern part of Argentina and seeing sea otters being hanged in a tree by indigenous communities. So we know there's been hunting for many, many hundreds of years. So it seems that it took a couple of generations for them to learn fear of humans, and now there's still a lot of fear. That's why most of the investigation that's being done in sea otter uses trap cameras. It's cameras that are fixed in a place, and when there are no humans around, they go out of their nest or they go out of their home, and they can move around freely, and the camera then snaps a shot of them, and we know how they move, and then we know how their groups are occurring. So yes, they're very they have a lot of fear of the sea otter, but you can still see them when you go on boat, though, eating mostly. But if you get a little close to them, they will swim down and hide away real quickly. But yeah, it's hypothesized that it's a generational fear that has occurred throughout the hundreds of years of hunting.
All right, and that's completely fair enough. Daniel, thank you so much for being with us. It was really great to see the next part of your video with the threats they're facing, and also to hear a little bit about what needs to be done on the conservation side of things. So yeah, Daniel, it was great to have you join us from Peru today. These world's most exciting classroom events are always fun. We're always bouncing all over the world.
Thank you, Joe, and thank you, everybody. It's good seeing you again.
All right, let's get a wave here from our grade sixes. There they are. Awesome. Okay, well, Daniel, thanks so much. And who knows, maybe we'll connect with you again. We'll do the final video at some stage. We still have almost a year to go before the Oosterschelde gets back to the UK. So thanks, Daniel.
Thank you, Joe.
All right. Perfect. Well, it was great to spend a little time with Daniel. While Daniel was presenting, I pulled together a little Kahoot quiz behind the scenes, so we can play a little Kahoot quiz together before we move on to our next activity. So just bear with me. I'm going to share my screen here. And actually, before I share my screen, I need to make sure that I hit start. There we go. Perfect. So I'm going to share my screen, and then we are going to play some Kahoot together. So to join for Kahoot, there's many ways you can do it. One, if you have tablets or Chromebooks or something like that, our number is 671-625. If you don't have technology at your seat, maybe your teacher could pop this up at the front of the room and you can shout out your answers to him or her. Or if you can't connect, just give it a try and see how you do with your answers. If you're at home, we always have lots of home students joining us. You can use that QR code, scan it with a phone, scan it with a tablet, and it will bring you into the Kahoot. I see we have some classrooms, some students joining us, which is great. We'll give it maybe another 30 seconds and then we'll get things started. I do want to just tell you a little bit about what we have in store for the rest of today's World's Most Exciting Classroom. We have a brand new experiment for you that you can try in your classroom for a chance at some prizes. Of course, we have a new curiosity of the week, and we'll look at the answer to last week's curiosity. And then we have a special event I recorded last night with some cave divers in Indonesia. So you'll recognize two of them if you've been with us before. They were on the ship as researchers in different parts of the world. So we're going to take a look at their adventure that they're on right now, exploring caves 4 kilometers underground. They're diving over 4 kilometers into these caves. It's absolutely incredible. And we're going to catch up with them and see how they're doing in the field. Okay. So here we go. I think things have slowed down. I think we can play some Kahoot. All right. Remember, there's true and false. There's multiple choice. Everything in here is something Daniel talked about during our little time together. And our first one is multiple choice. Where was Daniel a Darwin leader? Was he in Peru, Chile, Argentina, or Brazil? So don't get fooled where he is right now. But where was he a leader? Peru, Chile, Argentina, or Brazil? So you have 4 South American countries there as your options. You have a couple more seconds to squeak an answer in, and then we'll find out where. Oh, perfect. So, we had a little bit of a trick there because, yes, Daniel was in Peru. That's where he lives, but he was a Darwin leader in Concepcion, a town in Chile. So good work to those students. I know that was tricky because we talked about Peru a lot and we talked about Chile a lot. So that's great. Let us go to our next question. Oh, right. Our leader, Blue Panda in the lead, but let's see what happens with our next question. This is a true or false question. Sea otter numbers have rebounded and increased in the area since being protected. Is that true or false? They've been protected now. Have their numbers started to go up? True or false? You've got about 10 more seconds to decide. They have been protected now. Have their numbers started to go up? True or false? That they've gone up. All right, good job, crew. That is false. Even though they've been protected from, in some cases, habitat loss and hunting, which were the 2 biggest impacts, their numbers still haven't started to increase because there's still things happening. And we're going to have a question about that in just a moment. All right, Blue Panda is holding on. We've got another multiple choice coming your way. You have to pick 2. Pick 2 answers here. What 2 issues caused sea otter numbers to drop before they were protected? So they're the 2 biggest issues that Daniel talked about. You need to pick those 2 big issues. Was it loss of habitat, climate change, pollution, and hunting? All 4 of those could be affecting sea otters, but Daniel highlighted 2 that led to their numbers to fall in the first place. Was it loss of habitat, climate change, pollution, hunting? You need to pick 2 answers for this one. All right. Good job, crew. Loss of habitat and hunting were the two biggest issues. Now, more recently, things like plastic pollution, diseases, climate change, melting glaciers, those have been having impacts on the sea otters as well. All right. Blue Panda is holding on tight. I think they might hold it tape to tape, but we've got one more. Plastic pollution is a new threat facing sea otters. True or false? That plastic pollution is a new threat now facing sea otters. You have about 14 seconds to get your answers locked in. All right, absolutely true. And it's not so much that they're making mistakes. So sea turtles make mistakes, right? Plastic bags, pieces of plastic, sometimes look like jellyfish and the food they eat. But for the otters, because the plastics get into sea urchins and sea cucumbers, the microplastics, they then ingest them when they eat their favorite food. Let's take a look at our podium and see how we're doing. In third place, we've got the Speedy Possum. In second place, we have the Diligent Bear. And in first place, the Blue Panda was able to hold on. Very, very cool. If you are the classroom with the Blue Panda, I need you to do me a favor and send me a message to classroom@darwin200.com. I'm going to put that up here on the screen for you. Where is it hiding? There it is. Classroom@darwin200.com. Send me a message and we will get you a £50 Amazon gift voucher that you can use for your classroom. So if you are the panda, the Blue Panda, if you're in that classroom, we want to send your class a gift card that you can use to do something cool in your classroom. All right. Well, we need to get to our experiments and then we will do some time with our cave divers. So before I do our brand new experiment, 2 weeks ago, we created our own bird feeders. So Stu was in the Darwin studio and he built a bird feeder. Let's take a look at what birds came to visit his bird feeder. So this should come up for us right about now.
Welcome back, everyone. How did you get on making your very own bird feeder? Well, I'm very happy to report that my one was very popular in my garden. Here's some shots of it. The most common species of bird that visited the bird feeder in my garden was this beautiful juvenile blue tit. There were quite a few of them that came over a few days. Look how hungry he is, pecking away. He really likes those seeds. Other species of birds did visit, but it wasn't just birds that are attracted to this bird feeder. This cheeky squirrel really liked it too. I could only get a shot of him. He was really hungry and I think ate quite a lot of the seeds. It was really great fun watching all the birds come to the bird feeder, and hopefully they had a good meal that'll help them get through the summer. Which species of birds came to the bird feeder in your garden? Quite a few of you sent in photos. So now let's go back to Joe and see some of the species that were attracted to the feeders that you made. Well done, and thank you very much for taking part.
All right. So I made a feeder of my own as well, but I put peanuts in my feeder instead of seeds on the peanut butter. And my backyard was full of blue jays. So we have a lot of blue jays in the neighborhood, and that attracted a lot of blue jays to the backyard. Now, we would still love to see more pictures from your classroom. So now is the perfect time. The weather is changing. If you're in Canada and the US, things are getting colder. So if you want to try and make a bird feeder to put out at your school or to put out in your backyard, we'd still love to see some pictures. And if we do see a few more pictures in the next week or two, we still might have a prize or two that we can give out to some students. So do try and make your own bird feeder. You can do the design Stu made, where he had a toilet paper roll, peanut butter on the outside, and seeds, and then hung it from a tree. Or you could do like a milk carton or something and put seeds inside. There's all kinds of different designs you could try and attract birds with. So we still hope to see a few more pictures come in from classrooms over the next few weeks. And now is a really good time when birds are looking for seeds to migrate. And as well, it's getting harder and harder to find those seeds. So you'll attract more to your backyard. Okay, brand new experiment. I have it here in front of me, and we're going to do it live together. at least set it up. And then we'll see the results in a couple weeks. But the first thing I need to do is share my second camera. So extra camera. And let's make sure I pick the right one. There we go. So you should see a second camera come into the call. There we go. And I'm going to tuck myself away so we have this nice big camera view. Okay, so I was thinking about what to do for an experiment. And with it being fall, and I interviewed someone the other day who talked to me about the world's loneliest plant. And that got me thinking about something she said in the interview, is that oftentimes we ignore plants. We think about the animals because they're big, they move around, we like the way that they look, but we forget that plants are living things as well, and that they are incredibly important to the ecosystem. They're the primary producers of energy, taking energy from the sun and converting it into sugars that could be eaten by herbivores and omnivores, and then they in turn are eaten by carnivores. So we forget about our plants sometimes. And today what I want to talk about is photosynthesis and how plants breathe. And we can't see that. It's not like us where we make a noise, we can put a hand in front of our mouth and we can feel air coming in and out. It's much harder to see with plants. But with today's experiment, very easy for you to try in your classrooms, we're going to talk a little bit about how plants breathe. So we have to talk about photosynthesis. So plants take two things. They take sunlight and they take carbon dioxide that we breathe out, and they bring that in, and then they convert it to some things that are really cool. Oxygen, which we need to breathe, and then sugars like glucose, which then can be eaten as energy sources for herbivores. So that's what's going on with photosynthesis. We're taking the sunlight, we're taking the carbon dioxide, and then the plants convert it into glucose and oxygen, which is pretty cool because those are two things that we very, very much need. So for today's experiment, we're going to try and see if we can see plants breathe. And what we need to do that are some clear containers. So I have one, I have two, I've got three, and I have four. I told you today's gonna be really easy. There's not a lot of supplies that we need to make today work. I have these bowls filled with a little bit of water, 1, 2, 3, 4. And then I went out this morning and I gathered some leaves and a few different kinds so we can see things in a few different ways. I have this maple leaf. This is one that hasn't changed color yet. It's still alive, was taken right from the tree. I'm going to put it into this first one. So I'm going to put it in. There it is. I took this one, which fell off of the same tree. This one is changed color and it's fallen off. So I want to see if a leaf that's no longer on the tree is still breathing or producing oxygen. So I'm going to put this in the far one. There we go. I wanted to mix things up a little bit, so I got an evergreen. This is a cedar. These aren't going to change color or fall off. So I'm curious what things will be like with a conifer. We also call them evergreens. So I'm going to put that into this one. And then I took one more. This is from a hosta. And this one hasn't changed color yet. I took this right off of the plant. And I'm going to put it into, let me put it upside down because it's got this piece sticking up. And then the last thing I'm going to do is just with some rocks, I'm going to weigh it down so the leaf is submerged underwater. So I'll submerge that one. I'll submerge this one. We will do this group and then this one. Now, what I'm going to do after our call today is I'm going to take 1, 2, 3, and 4, and I'm going to bring them upstairs and I'm going to put them in the window where the sun can shine on them. Now, this is a slow experiment in that it'll be several hours before you see some results, but I want you to look very carefully and watch after a few hours and see if there are something being produced on these leaves. So you might have to look very carefully. If you have a magnifying glass in your classroom, that could help as well. So I want you to take a look at these leaves after a few hours. So try to get some live ones that are nice and green. Also, try one like this one here that has fallen off and see if there's a difference. And if you really want to get creative, try from like a conifer. In this case, this is from a cedar. So that is our experiment. We're going to find out if plants. We can see plants breathing, and that's why we put them in this water. And then we are going to leave it in the sun for a few hours. And then we want to see your pictures. Take pictures of your results. Send them to us at classroom@darwin200.com. You have 2 whole weeks to work on this experiment. There is not many materials, some glass containers, leaves from outside, and some rocks. So this should be pretty easy for everybody to do and to give a try. We want to see at classroom@darwin200.com, and then we'll have a chance at some prizes for you as well. Okay, let's get my other camera back here and running. There we go. And we'll turn off this one, classroom@darwin200.com. Now, I promised you some cave divers, so let's meet our cave divers. You might remember Ranva. You might remember Maria. They joined us as researchers on different legs. Ranva joined us when we crossed the Atlantic Ocean and went to Fernando de Noronha in Brazil. And then Maria joined us more recently when we were in Mangareva, and she went to Papiti with us. Both of them did coral transects. So they got into the water, they swam along lengths of coral, they took pictures, they took measurements. So in the future, people can go back to those same areas, take photos and measurements, and see how things have changed. Is the coral still healthy? Is it growing? Or is it gone? Is it dying? Has it been bleached? What has changed since the transects were taken? So it's a great way. They took baseline data, what things look like now, so we can see what things look like in the future and how they're changing. And there are 2 incredible cave divers. So they're good friends. They work together. They have an expedition company called Nixie Expeditions. They are on a little island in Indonesia right now with a whole team, and they are cave diving. I'm just going to play the video because we want to see what they're up to. So bear with me while it loads, and then let's see what they are doing. Now we're going to bring in our first guest speakers, and I can't think of a better group to be spending a little bit of time with. We are going to head to Indonesia, to a little island called Palumuna. And we're going to meet Expedition Butang. But before we do, I have a map here that I want to share really quickly, just so you can get a feel for where we are going in the world. So I am going to bring this map up front and center. I'm going to pick the right one. There we go. So I'm going to back out a little bit. So there's Australia down there. And if we zoom in to Indonesia, and oops, I think I lost the island when I zoomed out like that. So I might have to type in the name really quickly to get it to come back. There we go. Ha, perfect. So if we zoom in, this is where we are in the world, in Indonesia. And we're going to meet this team right now. So Expedition Butang, they are exploring and studying the aquifer and surrounding caves. It's an international team of cave divers, dry cavers, scientists, photographers, uniting with local authorities to map the cave system, assess water quality, collect eDNA, assess community needs, and document the beauty of this cave. Let's bring them in right now. There we go. Ranva and Maria, how are we doing?
Good. How are you? Nice to see you, Joe.
Yeah, so this is extra special to have Ranva and Maria here because they were both scientists on board the Oosterschelde from the Explorers Club. They did coral transects for us in very different parts of the world. One in Fernando de Noronha, a little island off Brazil. And then we had you joining us, Mangareva, and parts of Tahiti, Maria. It is so good to see the 2 of you.
Likewise, good to see you again, Joe. And what an amazing opportunity to be able to stand here in Indonesia, live streaming through DARWIN200. Thank you so much. It's so exciting. It's so hot here.
Yeah, I know. Exactly. So, so just a quick introduction of who we are as well. Like you said, we've both been on DARWIN200 ourselves. I actually managed to cross the Atlantic on the Oosterschelde, and I got to sail past the equator and got baptized by King Neptune as well. But beyond that, I am, as you said, a member of the Explorers Club, and Maria and I are the founders and project managers of Nixie Expeditions. And this is a project that we spent about 2.5 years setting up.
Yeah. So my name is Maria, and I was so fortunate to be on leg 18 where we were diving. I was diving in French Polynesia, from the Oosterschelde in underneath pearl farms, collecting data on the coral reefs out there. It's absolutely incredible. And as a professional diver, I'm standing here as part of the scientific dive team. Ranva and I are collecting data in the cave, and we will be spending the next couple of DARWIN200 live streams telling you about this project and showing the details of it. But we have some team members here who's going to take over from us, explaining more in details what we're doing out here, because we're going to go diving inside the cave now. So here,
Yes.
hi.
Hello.
Hello.
How are you? My name is Christine. I am what's called a science coordinator of Expedition Bhutan.
Yep. And
And
also I'm Ida. I'm from Indonesia. I'm the scientist here to do some study for the extraordinary cave. So
so we're really excited to be here because not only is this an expedition with divers exploring some of the unexplored parts of Earth,
Yep.
but we are coupling science with it,
Yep.
so it can go out to the community, and hopefully we learn something about like evolution history, species diversity, all that kind of cool stuff that nobody knows so far. So we're really excited.
Yep.
But what you see here behind us is the entrance to the cave. So in a few minutes, Ranva and Maria are gonna go down there, and they're gonna take about 180 steps down. There's a little staircase, and then they're going to dive into the water, and it's like almost 4 kilometers in, so it's really exciting. Yes, but we can show a video of Ranva preparing for how to prepare for a dive.
All right, excellent. Give me 1 second here to load up the video, and then we'll see how she's preparing right now.
Okay.
Buddy, can you give me a quick brief on what we're doing now on this dive?
So this is dive number 3 in Laulawi. So we're going back to each of the research stations or sampling stations, and this time we're going to be sampling fossils. So ideally a piece of coral and a piece of shell into our falcon tubes, and then we need to go back to station 4, which is the 4 stations we've installed so far, and then Robin is going to take us to a proper saltwater passage. We haven't found one yet, but he knows where there is one. Station 4 is brackish, and when we get to station 5 in the proper saltwater passage, that's where we're going to do 4 water samples, 3 for eDNA and 1 for biology. And then we are, no, for Vira, right, metagenomics. And then we're doing a sediment sample, and we're doing fossils as well on station 5.
Yeah, so that was it's actually quite a bit that we are collecting, that we're sampling there. So but just to show you also how the divers look when they need to go underwater, they are quite equipped with all kinds of stuff. We can show you a video of Natalie on the way to the cave. Yes. So Natalie is one of the divers that are going deep inside the cave. And you can see she's not a very tall person, but she's just heavily loaded with all kinds of
legs under that.
I know. You should see me in background at double. That's hysterical.
Ah, bless. Hello, yeah.
Yeah, awesome. And I can just turn around and then you can see everyone here. There you go. So we have divers preparing. We have a lot of people helping us as well. Getting the tanks ready, getting the tanks down. When you're diving, you're not supposed to do hard work, because then you are exposing yourself to decompression sicknesses. So we also have a picture of how it looks when they're in the water, down at the cave, and it's pretty cool. So you see, it's completely darkness down there.
It's totally dark.
Yeah, and the only light is the light that they that they bring themselves.
Yep.
But it lights up the water like a little swimming pool.
Yeah, like a swimming pool.
Yeah. I think we also have a video of when they're diving.
Yep, inside. They're diving inside the cave. And maybe we can see the video.
There you go.
Yep. The cave is totally submerged with the water and it's totally dark. They need lights to help them to see what inside the cave. And you can see the ornament inside the cave. It's so different with the outside. And the water is sometimes clear, but it's mostly clear water inside.
And then they're lighting up. So the cave is like covered in stalagmites and it's covered in ancient fossilized corals. And they get to these different sections. So at one point they have to like squeeze in through a narrow hole, and the next point they have like this giant opening covered in the stalagmites and stalactites, and it's really amazing, and it's really worth conservation efforts.
And yes, beside diving in the cave, we also study the cave. We study about the we study about the biology of the cave, also the geography, geology, also the hydrology. But before, maybe we see the okay, and then we can see the picture of me doing like some science project inside the cave. Yep. What I'm doing in the picture is I'm filtering the water because I want to know about the organism and animals that live inside the cave, since we so hard to know by our eyes. But only with the sample of the water, I will get the information of animals that live in the cave. That's so interesting, and so it's like a magical thing that I do, but it's like so interesting to study.
Yes.
Yes.
And we also have more team members on the science team. I think we have a video of your colleague from
Yes.
University of Gajah Mada,
Yes.
Abdul.
Yes. And we can see the video.
Yes.
When we are doing our filtering, a bit dark, but still we can see like we are doing since we have to collect the DNA, so we need to very sterile, but that's okay in this field. That's okay. It's not too sterile. And then Christine helped me to prepare the equipment. Yes. We collect the water from the diver, and then the water. Then I will filter, and then we get the information.
Exactly. And as you can see in the video, it's getting dark. It's because we have some really long days. So all the preparation takes time and the dives takes time. They're really challenging to go inside the earth to do this. So, and obviously the science also takes time.
Yes.
But it's so funny when you are inside the cave, it's dark. Then when you come up, so you lose a sense of time actually when you're down there. And then when you come up, it's it's also dark. So,
Yes.
Yeah.
We don't know time. Time goes by. It's just in the cave.
Time goes by.
Yeah, and I guess when you're underwater in a cave, it doesn't matter if it's light outside. It's always going to be dark in the cave. So whether it's day or night, it doesn't matter if those days go long. But I imagine that the divers, the science team really enjoy their rest too in between the dives.
They do.
Yes, it's also a good teamwork between the divers, also the scientists, also the people here. We have a good teamwork.
Yes, yes, we do. So that's awesome. I think actually our divers are ready. Our science divers are ready to go.
Yeah.
So here you have
something very important. Hello. Hello. You said something very important about the cooperation between us. I mean, we need each other out here. So our task is to dive in and collect stuff from the cave that the scientists are not able to go and get because it's a long journey under the ground, and we are specialized using this equipment to do so. But we will make sure that next week we'll come back with some videos of more details of the cave, because it has amazing fossils and beautiful decorations of crystal, and in general just a stunning cave, and there are creatures living down there, and we might catch some for next time, and of course for the scientists to look into.
Yeah, and we're bringing a very special flag with us as well, which is the Exploring by the Seas of Your Pants flag. And that is coming diving with us today, and we'll have some pictures with it underground in the cave of Laulaui on Muna Island.
So cool. Well, listen, have a great dive. Before you go, I want to ask you a really quick question. We have some classrooms in Australia sending in questions. And the first question here that they'd like to know is, don't you find it scary going down into the dark cave?
Well,
You want to answer that one?
you want to answer? I don't actually, because we bring so much light with us. We need to have backups of everything. So this is a big primary light, and then you have one backup light and then another backup light. So between us, we have 6 lights. So we will never run out of lights down there. So it's not scary. It's really exciting. And what you can see is something that very few people on the planet are able to see. It's like diving into the inner space of our planet. You feel like an astronaut going into the center of the earth.
Yeah, absolutely. You get so mesmerized by these caves because they're ancient coral reef. Whilst you're diving through it, you constantly notice new things. Like I was saying before, fossils. There are perfect fossils of corals and giant clams down there.
That are
beautiful.
This big. Never seen anything like it anywhere in the world.
So every time we go underwater, we literally venture back in time, and it is thrilling and exciting. Of course, it also takes some concentration because we are underwater and we are underground, but good teamwork and lots of training, and then the experience is just absolutely amazing.
All right. I know it's hot, so I'm going to ask one more question from our students. How long do you think this dive is going to last?
Well, yesterday we did 3.5 hours. Today is a short dive, so we're gonna do about 2 hours today, I think. But with these rebreathers, as you can see, these are scrubbers here. We can do a little bit more of an equipment check or a run through next time we're filming if you find that interesting. But with rebreathers, we can be underwater a really, really long time because rebreathers recirculate the air. So they're very, very efficient in how you use gas.
Yeah.
So they can bring us safely a long way into the cave and back again.
So we're like little ninjas underwater because we have no bubbles. We just glide through the water, and it's super quiet down there. So we're gonna have about 2 hours today to look around.
All right. Well, have fun on the dive. Stay safe. We can't wait to hear how it went.
Thank you. See you next week.
All right. Thanks, everyone. See ya. Okay. So cool to be able to talk to them last night. They were using a Starlink unit. I gave them one of our satellite units. It's only about this big, and they brought it to Indonesia with them and connected live. Now, right now, they're sleeping. The time differences are so different. So that's why we need to make the recordings. But wow, diving in those caves, 4 kilometers into those caves, seeing those areas that very few people on the planet have ever seen or will ever get a chance to explore. It's pretty amazing. Before we do our curiosity to wrap up, I just want to check in with our grade 6s and see if they have any questions about the cave diving, because I know a lot about the expedition and I might be able to answer if you have a question or two. If not, that's okay. We can go on to the curiosity of the week, but I thought I would check in just before we wrapped up with the curiosity. Hey, gang.
Hello.
Hi.
Is there any animals in the caves? If yes, then what types of animals?
Yeah, so the animals that they're going to find in the cave, actually, I've got a picture here. Let me see if I can pull up the picture really quickly. Where did I put the pictures? I can show you one. It is, oh, maybe I don't have it handy. Darn. I'm going to check one more place for it, but there are animals in the caves. So in the dry part of the cave, before you go in, you're going to find more. You're going to find insects. You might find some little reptiles or amphibians. And then you're definitely probably going to find some bats because they like to use those caves. So definitely in the dry part. Now, when you go into the water part, there are still living things, but they're small. There'll be things like microbes, which that they're testing for in the water and on the rocks. And then sometimes there's little tiny cave creatures that you can find as well. And they're usually really neat looking. They're usually white because there's no need for color. It's dark. It can't be seen anyways. And a lot of times they're blind. So one that comes to mind is called a remipede. And you find them in caves in the Bahamas. And they're only about this big, but they're the top predators. So they bite other things and they suck out their insides like a spider would. So that's pretty cool. I did find a picture here, so I'm going to share that picture right now. This is a picture from the dry part of the cave. This is kind of like, it looks like a little scorpion, but it's actually something called, I believe they're called whip spiders. And so they have kind of, let me zoom in a little. They have kind of these pincher arms and then these long legs. And this one is covered in young. It's carrying its babies around on its back. That is so cool.
Oh my gosh.
Look at that. So there are definitely things in the dry part. And then there are really small creatures that they're sampling for in the underwater, the wet parts of the cave. Pretty cool. All right. Great question. Do you have another one there?
Ben.
Looks like we do.
Okay, Ben, quick.
So, like, we know, like, the fossilized clams, like, how big are the clams, though?
Yeah, they were saying that they were seeing really big ones. I think Maria was saying they were seeing clams that were probably about almost like a foot large. And that sounds really big, but I was diving a few years ago in Australia on the Great Barrier Reef, obviously coral reef, and some of the clams that I saw were a meter long.
What?
And they were alive, which was really, really
alive?
cool.
They're alive?
Still alive and still filtering water. So when they're seeing that ancient coral reef and they're seeing those clam fossils, I bet they're anywhere from like a foot, maybe all the way up to a meter, which is pretty cool.
Dang.
All right. If there's one more, we'll squeeze one more in, then we'll do our curiosity of the week to wrap up.
So have you ever discovered, has anyone ever discovered like a new species inside the caves?
Oh yeah, all the time. So these caves, a lot of times divers are going into these caves and they've never been explored by humans before. So I guarantee that if they're sampling the water in there, excuse me, they're going to find new things. Could be bacteria and microbes, could be tiny little insects or little crustaceans. I bet for sure that out of this expedition, they're going to find some new species. Absolutely.
Okay. Thank you.
Cool. One more? Go for it.
What's the biggest animal in the underground caves? Like, one of the biggest?
I don't know for sure in their cave, but I do know in caves in Indonesia that sometimes snakes will go in there. So big snakes like constrictors, like pythons or boa constrictors, and they like to wait in the caves to try and catch the bats as they fly in and out of the caves. So some of those can be several feet long and get pretty thick too. So my guess is that they'd be probably some of the biggest things going into the caves. And then obviously the people too, when they go and visit those caves. But living in there, I think probably something like one of those big snakes. And depending on where they are, maybe even things like deer might go into the caves from time to time. But yeah, that's my best guess for that cave in that part of the world. All right. All right, great sixes. Thank you so much. Great questions. So we need to wrap up now with our curiosity of the week. Last week we had a curiosity. So let's take a look at the answer to last week's curiosity. In fact, I have one right here. This was our curiosity from last week, but we have the answer here from Stu. So let's take a look.
Back, everyone. Last week's curiosity was to try and identify this giant fossilized tooth. to work out which animal it belonged to, when that animal was alive, and how big it could become. Well, many of you sent in answers over the last week and got it absolutely right. This is a megalodon tooth. Megalodons were ancient, gigantic sharks. Look at the size of this tooth. Imagine the mouth that was in. Perhaps luckily for us, and certainly for all of the animals alive in the ocean today, megalodons are now extinct and no longer alive on this planet. The word megalodon means large tooth, and you can easily see why. Believe it or not though, this is a relatively small one. They can get nearly double this size. So just imagine that enormous animal that had a mouth of these gigantic teeth. The second part of last week's question was to research when megalodons were alive, and many of you also got this right as well. The fossil record shows that they appeared around 23 million years ago, and they disappeared and became extinct around 3.6 million years ago. So I'm glad to say that they didn't overlap with any of our human ancestors. The third part of last week's question concerned how big megalodons can grow. This is still a bit contentious today, but most experts believe that the very largest megalodons could exceed 20 meters long. That is an enormous shark, and it's thought that it was such a powerful predator, it severely impacted the balance of life in the oceans for those millions of years when it roamed the seas of the world. Did you answer correctly? Now let's find out who won this week's prizes. Thank you for taking part.
Okay, so there we go. That was the answer to our curiosity of the week. It was a megalodon tooth. As you can see, they're pretty cool, pretty big. And like Stu was saying, they can get a lot bigger than this example here. This one was found in the ocean in North Carolina. So there's spots you can go and dive and then feel around on the ocean floor and find these fossilized teeth. And this one still has a serrated edge. It's actually still kind of sharp, which is pretty amazing considering it's millions of years old. We had lots of answers come in, lots of correct answers. I think a lot of students know about Megalodon, especially from watching Shark Week on something like the Discovery Channel. So great work to all the students who sent in answers for the Megalodon tooth. And we need to look at this week's curiosity before we say goodbye today.
Back everyone. This week's curiosity is this beautiful blue butterfly. Look at its amazing iridescent shiny wings. I've deliberately covered up its name at the bottom of this specimen case. Can you research blue butterflies and work out what type of butterfly this is? Also, how and why does it have this electric blue iridescent shine to its wings? Send in your best guesses to classroom@darwin200.com for a chance to win an Amazon gift voucher prize. Join me next week to find out the identity of this beautiful blue butterfly.
Okay, so there we go. That's our curiosity of the week. Remember your homework for this week, the next 2 weeks, I guess. The first is the experiment. Try the leaf experiment. Find some living leaves, find some leaves that have already fallen off of the trees, excuse me, and then put them into the water and see if you can capture evidence of those leaves breathing. Send in those pictures to classroom at darwin200.com of your class, giving that experiment a try. You have 2 weeks to do that. And then our curiosity of the week, 1 week to send in your answer for what you think this week's curiosity is. So we're going to say goodbye for now. Before we do, though, we always end off with a shout out to our sponsors and supporters, without whom we couldn't be sailing around the world's most exciting classroom, bringing young Darwin leaders and researchers out onto the ship. So goodbye for now. We'll see you next week, and we will wrap up with a thank you to our sponsors.